Hi guys, so here is your lesson for Monday, June 2nd. Okay, lesson number 8. We only have 10 lessons in this unit and then we are done for the year. So, this is linear quadratic systems, okay? So, we've talked about solutions before, okay, and systems before. Remember, a system of equations is two equations and two variables. So, if you look at each equation here, both of them have two variables and they have an intersection point. So the solution is where the equations cross or intersect, right here. So what is the solution to this system of equations? 2, 3. This should all just be review. So what we're going to talk about today is when we have a linear line, which means straight, and when we have a quadratic line, which looks like a parabola or a hill, like a mountain or a ditch, that we've been talking about for this entire unit. So we have 3 examples here of systems, okay? The first one gives us, let me make a different color here. The first one gives us 2 solutions because they have 2 intersection points. Okay, so the first solution would be -2, 0. And the second solution would be 1, 3. If we look at the second picture, we have one solution because they only cross at one spot. Okay, the solution would be 0, -2. And if we look at the last picture, we have no solutions because never, ever, ever are they going to cross. Even though they keep going on forever, they will never cross paths. So, example 1. The graph of f of x minus x squared plus 1 and g of x equals x minus 5 are shown below. Okay? For the given system, state the point of intersection to the system. So we can see they have 2 points of intersection, and we're just going to state the points. So the first point, and you might have to fill in some numbers, is -3, -8. And the second point is 2, -3. Okay, state the solutions, the x values, remember solutions means x values, to the given system of equations where f of x equals g of x. That sounds complicated, but all it's asking you to do is give me the x values. My x values are x equals 3 and x equals 2. Where literally, I'm just taking it from the points here. -3 and 2. That's it. Okay? So example 1 continues. It says, let's look at a table for each function. Okay, you're going to use GeoGebra for this. Or you don't actually have to. If you want to just take the points that you see on the graph, you can state the points. But it wants you to create a table of values. So I'm going to go from maybe -4 to 4 to get a list for each one. So the x values I'm going to go with are -4 to 4. -4, -3, -2, -1, 0, 1, 2, 3. Same thing. Okay, and now I'm going to fill in the y values for each equation. So I'm first going to start with my f of x equals x squared plus 1. Okay, that's this line here. It's the parabola. So when x is -4, and you can't see it on here, so this is why you might have to use GeoGebra. So I'm going to go to GeoGebra, and I'm going to type in my equation. I have -x squared plus 1. And you can type in f of x if you want, but it'll put it there for you. Okay, and I'm going to use my table of values, and I'm going to go from -4 to 4. Press OK. And I'm just going to use all those f of x values as my y values. It's the same thing, and fill in the table. Okay, so you should have -15, -8, -3, 0, 1, 0, -3, -8, -15. Okay, now let's do our other equation, or g of x. Here's my g of x. Okay, and I'm going to type that into GeoGebra as well. X minus 5. Enter. Table of values. And it actually, look, you can see side by side, okay, you have your values for f of x, and then you have your values for g of x. So I'm just going to copy that into my workspace. So I have -9, -8, -7, -6. Oops, sorry. Can you guys shut the door, please? -5, -4, -3, -2, -1. Okay, and the point of this is I want you to be able to see the solutions here in the table. Okay, remember the solutions were right here where they cross. Okay, and if you notice, they share the same points. So we should see the same points of -3, -8, and 2, -3. Those are the 2 points that they have in common. Okay? Okay, example 2. Okay, it says graph the equations, and then we're going to state the intersection points. So I'm going to go back to my GeoGebra. I'm going to clear all, and I'm going to put my equations in. X squared minus 4x minus 5. Enter. And then I have x minus 5. Enter. Okay? You get a nice view of where they intersect. So I'm going to go to my workspace and I'm going to graph this. You can literally look at points and just graph the exact points that you see on here. Okay, graph all the nice points that I find. So my first one, I have x squared minus 4x minus 5. I graph that one in red. So I have -2, 7, -1, 0, 0, -5, 1, -8, 2, -9, 3, -8, 4, -5, 5, 0, and 6, 7. You can kind of see the pattern there. Connect all the dots as nicely as you can. Arrows on the end, and label it f of x. Okay, now I'm going to do my g of x. And again, if you want to look at a table of values, you can, okay? So if I wanted to look at a table of values, I can look at, I don't know, from -5 to 5. If it helps you graph, I'm just giving you an example, okay? And if you want to plot those points in your graph to help you graph, you can. Or you can just look at the points on the graph and use that instead. So I have -5. And it's just up 1 over 1, up 1 over 1. Real simple. Right on a straight diagonal. This is a poor line, but there we go. Okay. So, state the points of intersection to the system. We're just looking at where they cross. They cross at 2 points. Okay? They're going to cross at 0, -5. And 5, 0. Okay, so this was our 0, -5. And this was our 5, 0. B, state the solutions to the equation where f of x equals g of x. It's just asking us to state the x values. So I'm just taking them from here. X equals 0 and x equals 5. And that's it. Okay? Example 2 continued. Okay, this is going to, well, let me read it first. It says, solve the equation above by setting the equation equal to 0 and factoring. So we're setting the equation equal to 0 and then factoring. This is asking us to prove why these are the solutions algebraically. Why x equals 0 and why x equals 5 are the solutions to this system of equations algebraically. So we're going to use algebra to prove it. We should get the same answers as what we have here. X equals 0 and x equals 5. So it already kind of set it up for us. It took f of x and it set it equal to g of x. And we're going to set one side equal to 0. So this is the easier side because it doesn't have the x squared. So we're going to make this side 0 here. Okay? So I'm going to do that by subtracting or getting rid of, canceling out each term. So let's start with the x value. Positive x, the opposite of positive x is negative x. Okay? So if I do it on one side, I have to do it on the other. And I'm going to put it underneath the matching term. Okay, I'm not going to put it under x squared or 5 because that's not like terms. This is just like solving equations. Okay? My x's cancel out, and I'm left with negative 5 equals. Okay, the other side. X squared gets dropped down. Negative 4x and negative, this is like a 1x, becomes negative 5x. And I drop down my minus 5. Okay, I still have my negative 5 to get rid of right here. So I do the opposite. I add 5, add 5. My 5's cancel out, I'm left with 0. That's what we wanted. We wanted to make one side of the equation 0, and now we did it. Okay, negative 5 plus 5 becomes 0. I cross it out, and I drop everything else down. So now I'm left with x squared minus 5x. Okay, so now I set the equation equal to 0, and now I'm going to factor. Okay, so I take what I have. I have x squared minus 5, and this is where the factoring unit comes in. I want to factor. I want to simplify it. Okay, so what do they both have in common? Okay, it's not a trinomial, so we're not going to do AC factoring. Let's see if we can take out a GCF. What do they both have in common? Well, they both have an x value. So our GCF is x. Okay, so I'm going to take my GCF and divide both terms by my GCF. So here's my GCF, and remember I put it in parentheses, whatever we have left. X squared divided by x, well, actually I'm going to give myself some space here. Remember, x squared is like x times x over x minus 5x over x. I'm just writing it out. Remember, we cross out all the matching x pairs, and I'm left with x. Okay, I have minus 5x divided by x. Cross out the matching x pairs. I'm left with 5. So now that's completely factored. Okay, and notice, remember, don't forget, we're looking to get our answer to be 0 and 5. So now that it's completely factored, I'm going to set each piece equal to 0. X equals 0 and x minus 5 equals 0. Well, x minus 0 is done. Okay, I can't do anything else with that. There's one of my answers, right? Look at that. Matches up. Now let's get x equals 5. I'm going to solve for x. Plus 5 plus 5. 5's cancel out. I'm left with x equals 0 plus 5 is 5. There's my other matching solution. Okay, so it's just proving algebraically why those are the solutions. So what do you notice about the solutions? Well, the solutions match the x values of the points of intersection. So we just did this 3 ways, right? The x values of the points of intersection give us our solutions, and we proved it algebraically, okay, by showing this amount of work. Alright guys, that's it for today. Please take a look at the assignment. Good luck. If you have any questions, please let me know.